All right, now let's consider what happens if we had if some strong acid had been added in the solution. So the volume is still going to be 1 liter because the acid was added in before we went up to the 1 liter mark. So strong acids, they go to completion. So if we added 0.1 moles of that strong acid, it will react with equal number of moles of the conjugate base to form the conjugate acid. So we can just do subtractions here. We don't have to worry about setting up any kind of equilibrium. We assume it goes completely. So for the conjugate base, we had 0.5 moles before, and it's going to be reacting then with a strong acid. So 0.1 of those will react, leaving us with 0.4 moles of the conjugate, and that's in 1 liter. So now we have 0.4 molar. For the acid, we had 1 mole to begin with, but now we form more as the reaction has taken place. And so we have 0.1 more. So now we have 1.1 moles, again, in 1 liter. So now we can do the same thing again. So after this has happened, after we have added the strong acid, then a new equilibrium is going to be reached. And so we can plug in this table as well. So we have 1.1 now over here and 0.4 on the other side. As equilibrium is approached, you lose some of the acid as it reacts with water and ionizes, and you form more of the H3O plus and more of the conjugate. So we have 1.1 minus x, and 0.4 plus x. So again, the trick here is just to remember that there's a reaction with a strong acid that has been added, and you need to figure out the new molarities and then go back to your equilibrium table with those new molarities. So here we can set up with Ka again and do the same problem that we did before. And so we can make the assumption again that x is small, try it out and see if it works. X turns out to be 4.87 times 10 to the minus 4 molar. So again, it's a small number. And so it turns out to be less than 1% of 0.4. If it's less than 5% of the smaller number, you don't have to worry about the bigger number. And so your assumption is OK. You don't need to use the quadratic equation. And so then we can calculate at the end that the pH is now 3.31. Again, 2 significant figures after the decimal place because of the volume. So addition of 0.1 moles of a strong acid changed our pH from 3.45 to 3.31. So it buffered pretty well. There was a change in pH. We added acid, and the pH did go down, but not by an enormous amount. And so that's because this turned out to be a pretty decent buffer here. So we didn't have a really huge effect.